Alright, welcome back to another video where today we will be going over the intermediate volume theorem. So this should be new to most of you, but it's a very simple concept. And I do want to note that in your actual calculus course, your professor might do some more review on limits, but I decided to skip over limits because in my opinion, limits are quite easy. So I decided to just go to the next lesson, okay? So the intermediate volume states the following. Suppose that f is continuous on the closed interval ab, and let n be any number between f of a and f of b, where f of a cannot equal f of b, then there exists a number c in the interval ab such that f of c is equal to n. Okay, now that may seem complicated at first, but I'm telling you it's very easy, and I'm going to explain using a diagram because I feel it'll be easier to understand. Okay, so let's say a is here and b is here. Okay, f of a is here and f of b is here. Okay, we know that this would be a point then, right? And this would be a point approximately. Okay, going back to the definition, we're letting n be any number between f of a and f of b. Okay, so n can be any number between f of a and f of b. So it can be anywhere on the y-axis that's between f of a and f of b. So let's say n is here. Okay, then there is a number c in the interval ab. So let's say it's here, such that f of c is equal to n. Okay? And this will always hold true. So, for example, let's say you drew a line, right? Sorry, it's horrible drawing. Well, if you look closely, right, at first it may seem that, well, C being here and N being here, the point would be about there. How is it on the line, right? Well, it's because C doesn't have to be here. It just has to be between A and B, right? So if C was maybe perhaps, we draw a straight line, right? It's about there, let's say. We can draw C here. And as you can see, C is still between the interval a and b, right? And f of c is equal to the number n. What if the line wasn't straight, right? Let's say it was curvy, right? It's okay, but that's not in the interval, sorry. Let's just do that, right? Well, if we draw like that line, right? Well, we see that there's a point there, right? Well, then C would be here. And C is still between the interval a and b, right? So that's all the intermediate volume theorem states, and it's quite simple. Now, how is this used in tests, right? Well, typically you'll be given a question that says, show that there's a solution of, let's use this example. Okay, we have 4x cubed minus 6x squared plus 3x minus 2 being equal to 0. Okay, and let's say it being between 1 and 2. Okay, so right off the bat, well, first of all, I'm going to rewrite this as f of x is equal to 4x cubed minus 6x cubed plus 3x minus 2. Okay, right off the bat, we know that our interval is 1 and 2. Okay, so we can say a is equal to 1, b is equal to 2. Okay, and now what you want to do is you want to plug a and b into the function. Okay, so if you plug in 1, you get just 1. Or sorry, no, you get negative 1. Okay? And then if you plug in 2, you get, let's see, you get 12. Yeah, you get 12, okay. Right? Now, show that there's a solution to this function between 1 and 2. So what does that mean? Well, we're basically trying to show that the function crosses the x-axis, right? So we know that n has to, we want n equaling 0, right? Because if n equals 0 somewhere on this interval of 1 and 2, we know that there's a solution for the function, right? Now, if you look, right? If you look at our definition again, where let n be any number, n being on the y-axis, let it be any number between f of a and f of b, where f of a cannot equal f of b, f of a is -1, and f of b is 12. So we know that since the function at the x value 1 is starting below the x-axis, and the function at the value of 2 is above the axis, we know that the function must cross the x-axis at some point. So therefore, by showing that this is a negative number, right, at a, this is a and this is b, and that this is a positive number at b, we know that the function crosses the x-axis, meaning there is a solution to this function. Okay, so that's typically how you're given questions where you have to use the intermediate volume theorem. Now, I'm going to state some facts where the intermediate volume theorem does fail, right? So if it's continuous only on this interval where the function can equal b but not can equal a but not equal b, then this theorem could fail. If it's discontinuous between a and b, this theorem could fail. Okay. And then if f of a can't equal b, if f of a is equal to f of b, that does not imply that there exists c between a and b such that f of c equals a number n. Okay. Now these facts are important to know, but based on my experience when I've taken tests, usually when you have to solve a question involving the intermediate volume theorem, you don't have to worry too much about these assumptions, okay? You should know them, but unless you're going to become like a professor or get your PhD in mathematics, if you're given a question on the test where you're asked to solve or show that there's a solution using the intermediate volume theorem, you typically don't have to worry about these assumptions, okay? So that concludes this lesson.